Hello, everyone. Sorry about the technical difficulty here. My name is Hassan Namarvar, and I'm a data scientist at ShareThis. Today, I'm going to talk about the conversion estimation in display advertising using the H2O. So can I have the visual, please? So I've been using the H2O for about 6 months. Here I'm gonna, this is the outline after my talk. I'm gonna introduce the ShareThis first, and then I'll talk about the online display advertising problem and how we estimate the conversion rate using the H2O platform. And later on, I'm going to show you some results from live campaigns, and also talk about a little bit about the ongoing work at our company. And there is some time for the QA. So sharing tools at scale. What I'm talking about is a widget that we, as a company, we provide, and is a major source of our information. So this widget, the publishers can put the widget, which is the piece of the JavaScript, on their site, and they can get a variety of the sharing tools, such as Facebook button, LinkedIn button, Twitter button, and if they get our icon, so they can get access to our multiple sharing tools. When it boils down to the number, we are on 20, this is the 24 million actually, not more than 24 million websites, and actually, from the user perspective, although the user do not notice us, but that doesn't mean that we don't notice you. So it's we can reach to 210 million of the users, and in terms of the social channels, it's about more than 120 social channels, which is not only the US channels, but international channels. And we get about 23 billion page views, which is the incredible amount of the data. So just walking through how it works. This is Missy. She's busy chatting and browsing on the web. Missy reads an article and share it on her Facebook page using the ShareThis widget. And then ShareThis observe this activity and then target Missy and her friends with the advertising message tailored to their interest. So that's how, as a company, we make money. So every sharing, every activity on the social channel is meaning something profitable to us. So an example, we can do category targeting on technology, for example, and we have the, let's say, 28 million users with more than 35 million social actions per month, and per day it's about more than 1 million social actions. So, it's amount of the data is huge. On top of that, how we do the advertising, we do real-time messaging. We reach users during the peak interest. So let's say that Dan is a tech enthusiastic guy. So what the ShareThis is doing, we know that he's interested, and if there's something coming up, there is the excitement point that people, let's say, talking about the iPhone 6. It starts before it's released. So we gather the information at the right time, at the peak. We provide the ad. Usually this is the pattern. After something is really hot, the interest fades away. So that's how we do. We need to do it efficiently in order to deliver them ads on the right time and to the right user. So that's how it works. In general, online display advertising, the advertiser's goal is to target the most receptive online audience in the right time, right context, and influence them to go and make an action. And this action could be purchase of the product, to be the member of the service. So the advertisement system is a very complex system, so I just simplified it here. So how it works, whenever the user, online user, is browsing a web, usually if that website accepts the advertisement, so there is a request going to the ad exchange. And ad exchange is a marketplace. So there are buyers and sellers. There are lots of advertisers just listening to the request, and they have to bid. It's a very competitive market. It's like a stock market. So here, you have to bid on to win the place that you need to show the ad. So how it works, we have developed a real-time bidding system. This is a very complex system, but I just simplify it as in terms of the modeling pipeline. We gather our ShareThis data. We have the third-party data, and also we have the campaign data. We merge them together, and we build a model. And our goal is to predict that if this person is gonna convert or not convert. So actually, the goal of the ultimate goal of the advertisement to make you to go and purchase. And this is a very rare event, actually. So why is hard? Actually, before going to do that, the campaign advertisement basically have the multiple models, but these are the two major models. One model is based on the cost per click. So whenever you have you see the ad and you click on that, company makes money based on the number of the clicks, but that doesn't mean anything. You may not be interested. You may not buy anything. So the better model is the cost per action. Whenever you take an action and the company receive a commission based on that. So, and this model is called the CPA model, and this is the formula. If you predict the click-through rate, this is the optimal amount of the bid you have to place on every impression that you see. And the same thing, if we correctly estimate the conversion rate, so the optimal bid is given by if you know the CPA goal, you can estimate the bid. So the challenge here for both CTR and the CVR prediction, these are directly related to the user interacting with ad and in a given context. So fundamentally, this is a very, very hard problem because even CVR is harder than CTR because it's very, very rare event, and the order of its orders can vary from 10 to the minus 3 to 10 to the minus 6. And 10 to minus 6 means that out of 1 million impressions that you show 1 million times, maybe one person and purchase a product. So that's really, really rare event. And if you build a classifier that its accuracy is 99.9999, its accuracy is very high, but almost useless, so it doesn't mean anything. And also another difficulty comes from the view-through conversion. So probably, users are not convinced at the click time they exactly go to the website and purchase a product, because they have to think about that. Maybe, after a week, after 10 days, they come and then, make a purchase. So that adds another difficulty to the problem. So how we set up the problem? So this is very important. Let's define the users, publishers, ads, device, and location, like this set. The goal is find the optimal ad such that the probability of conversion is highest, given all those features. So if we have the multiple inventories, so this is the picking the ad with highest probability. But if we just have the only one ad, so we need to make sure that the probability is higher than a certain threshold. Then at that time we bid. So the problem is actually the same. So at the single user level, the problem is a binary problem, the conversion or non-conversion. So the conversion event is a random binary event. It's 0 and 1. And we know that for the random binary, the distribution is Bernoulli distribution. So at the transaction level, data features are poorly correlated with user direct response on display ad. So we have to solve this problem. If you look at the data hierarchy, let's say we have the user. The user can be, clustered on the different, segments, so, and the same thing for the advertisers. Advertisers can have a campaign and the different ad groups, and for the location, same thing. You could have the state, city, zip code. So you can, build the taxonomy around your data. And the idea is that we go and find similar groups, because if we have the historical data, we know that in the past how they have performed. And this is kind of, for sometimes you can think about that as a cold start problem too. But eventually, similar groups should perform, similarly within plus minus, variance. So how we do this? So we compute the conversion for, as I said, similar user, similar context, and ads. And this is not restricted to the 5 groups, 5 different dimensions here. It could be many, many dimensions, just an example here. And if you have enough data, so you can calculate the conversion rate using the maximum likelihood estimate. So if you have the enough impression data, so the PMLE is the best estimate that you can have. But if you don't have it, so that's the problem. How we solve this problem? We use the combining of the estimators, logistic regression estimators. So the problem is at each segment, at each dimensions, we could calculate the PMLE. And this could be the Q different level. And on top of it, we have the weak estimators on each dimensions. And from each weak estimators, we want to ensemble and build a stronger estimator. So that's why we use we need to find the function that actually maps the input to the probability domain. And if you use the logistic regression here, so this is like maximizing the log likelihood. So it's a matter of finding the logistic regression parameters. But this is not so easy to do because lots of practical issues here. And one of the practical issues is data is imbalanced. As I said, there is one positive sample and 1 million negative samples, very unbalanced data. We need to upsample the conversions or downsample the non-conversions. There are also anomalies on the data, so not for every campaign we have the conversion data. We don't have it, So in that case, we need to proxy the conversion. So what that means, we use the retargeting visits because we have the pixels in the site and we get the, the information from there. So we use that as a proxy for the conversion, but that could be the outlier because bots can come and then, visit that page and it skews your data. So you need to remove the outliers. And the missing features. Sometimes features are missing or you don't have enough data to compute the MLE. So we have to impute the features. And another thing is the feature selection because in some cases, that you have the features, but that features doesn't have the enough information, so you have to throw it away. And this is in the practice, we found that we could discard the feature if 70% of that feature is missing, or the variance of the attribution is lower than a threshold. But that's not only the problem, because the size of the data is really huge, and that's why the H2O comes to play. Why new machine learning tool? So you may ask that we have many, many tools in the past. How have people solve their problem? But yes, I have worked with several popular machine learning tools, but they have their own issue. What I need to see here as a critical feature for state-of-the-art machine learning algorithm, at least it has to be easy to use, reliable, it should be in memory, fast, distributed, accurate algorithm, and you can visualize the data and the result. And also, most importantly, easy to deploy to production. You don't want to build a model offline, everything is great, and someone implementing there and just forget about the minus. Only one, instead of positive, put the minus, and everything is messed up. So we don't want to do that. So we need to minimize as much as possible. Yes?
Question, how often do you update the model?
Yes, this model that we update is not frequently, because this is the global model, but we're thinking that in the future, when we have enough models on the production on different sectors, we could update it, on daily basis or weekly.
Global model,
only one model. Only one model. We have the global model here. Yes, good question. So we apply the. So that's the reason we use the H2O platform. And for the basic model, we use the GLM, logistic regression. Logistic regression always is the base model. It is a good model, and it's very, very elegant model. So here you can see that the ROC plot, the number of the amount of the data is huge. It's about the 14 gig data. It's about 7 times more than the Pareto-Kaggle problem on the CTR prediction. So, and we got the 77% AUC. And we calibrate another issue, how we do that on the production. So we need to find the best threshold from the AUC, and also the real problem in the production is that the ad server attributes the impression to the conversion to the last impression. So we need to sacrifice some of the impressions. So that's the one reason we need to be careful about that. So here is the block diagram. We focused on the retargeting users. We apply we deliver the ads at the optimal time, and we didn't waste so much impressions, and we hope that we get the better performance. Actually, we tried it. This is the one test that we used, the car insurance. Actual test, it ran for 2 months, and the measure is measured by the double click verification. So it's a third party, it's not us. And we saw a lift about 58% on this specific campaign. And we extended the work. So we tested on different sectors, on finance, hotel, casinos, cosmetic, newspaper, hotel, and also the department stores. And on all of them, we see the positive impact except one, which is the newspaper. And I need to go back and then figure out why, because although this is global model, you know, we don't know, maybe it's performed better, maybe it's performed worse on some campaigns. For us, it's one data point, but for them, it's a whole business. We can't tolerate that and the negative performance. So that's why we are doing continue our work, and we test. The test is very expensive and time-consuming. We need to evaluate the models before deploy to the production. So we build many, many models with different data sets, different features, and different algorithms. And here we use the gradient boost machine. So you heard earlier from Professor Hasty that these are very good the machines to estimate the probabilities for this type of problem. And we find it very useful. And here, as you can see, I'm not sure that you can see it completely or not, but I compared the GBM with 2 random forest models. And on the GBM, you know, we got the same amount of the AUC. The accuracy is about the same. A little bit RF is doing better, but the advantages is that because the GBM is really, you can see it in this graph, the GBM is the second one. Actually, the AUC is on the test set is very close to the RF. That's the best model. But we choose the second best because the scoring time is really, really fast. And this is very crucial to us because we tested in production. Scoring time for every impression is 1 microsecond. And we have the 10 millisecond to score. Yes?
So my question is, when you calculate AUCs and other metrics, are you doing it across? When you are calculating AUC and other quality control metrics, are you looking across all of your advertising campaigns, or are you looking for specific category?
Across across all campaigns.
So you're not measuring lift per every specific campaign?
No, it's not specific. It's global, actually. Yes.
So I see you're using AUC to pick the models.
Yes.
But you're just using the models to select the top 1/4% or something very small.
Yes.
Why not just select the best model at the top 1/4%? Why use the entire area, the entire score spectrum? Wouldn't it be better to pick at where you're deploying?
I will discuss it here because we need to, when we select the model in practice, we need to look at these things, you know, accuracy of prediction on unseen data, and the scoring time on the production, and the remove the anomalies using the, you know, we use the deep learning to remove the anomalies, and then the cycle is repeated, you know. So, and we need also, important thing is a correlation with the other campaigns KPIs, like how is it doing with the CTR, how is with the viewability. So the performance is not only our factor, so to pick the model. And the performance stability. For example, in this case, I looked at the scores with the CTR. So that means that if we find the positive correlation with the CTR with 1 day and the 10 days, so that means that, okay, user after clicking, there's higher likelihood that they can go and then convert. So we have to keep it. We have to look at that. Otherwise, if the outcome of the model is different than you know, this correlation, either we are doing something wrong with the CTR or with this model. And the same thing for the bidding price. For example, the bidding price on the higher conversion rate is expensive. That's what we expect. Otherwise, if it's cheaper, it doesn't mean that we are doing a good job. So in conclusion, so how H2O helped us? Maximize the ROI by optimizing campaign performance and budget allocation. Empowered us to use the advanced machine learning algorithm in Hadoop cluster, and we used all data to build the model much faster. We reduced the time, R&D time significantly. Otherwise, we have to work 1 year to deploy this kind of model into the system. And also provide us the nice framework to build a smooth model building pipeline using the R and the Spark API. And I have to thank you from my team. This was the teamwork, and so one single person cannot do this much stuff. And at the end, we are also hiring. So we are looking for very smart engineers and machine learning engineers. So please check out our website at Career webpage, or talk to me after the talk.
Thank you, Hassan.
Thank you. And questions, please.
So the first question is right here.
So another question,
Sure.
Are you doing anything about the time dimension? Because conversion rate could be changing over different time windows. Yes. So are you building models over snapshots of data? Are you weighing the more recent data heavier? What are you doing about all of this?
Yes. The question was about the time, the window time that the conversion is happening. We use the 1 week rolling window in order to match the last impression with the conversions. So we found that after 7 days, the conversion events become very rare. So we didn't use that longer.
No, that wasn't really my question. My question was the conversion rate can change over time.
Yes, that it can change because of the seasonality.
Right.
Yes.
So the question is, are you training the model over moving time windows?
Yes, actually, yes. Every week, that's the plan. We haven't done it, but that's the plan to capture the market dynamic. Every week or every month, our model should capture the dynamic. Yes, that's a good question.
Okay, the last question right here.
Do you have any opinions about normalizing for the propensity for a web surfer to click on an ad without any intervention? Because if someone may be willing to click on one of your ads and you didn't have to pay a very high bid on it anyway, so there's like this propensity to kind of like the previous talk, the propensity to buy. Do you ever try to model that maybe through random effects for the individuals or something like that?
Yeah, that's a good question, actually. We haven't done in that line, actually. So this is in the future, maybe. Yeah, we could take a look. Yeah, that's a very good point.
All right, that was the last question. Please ask your other questions later offline.